The Build Show Build Boston series is sponsored by Allura Fiber Cement Siding, Mitsubishi Electric Train US, Roseburg, Schüco USA, and Warmboard.
Hey, so we're back here at the job site. We finished our tour of that factory. Hopefully you enjoyed that. Those windows went on a pallet went on a truck, and guess what? You guessed it. The truck is here on site. Our windows are here. We're gonna get this thing pulled up. We're gonna get organized, and we're gonna get those windows offloaded, and we're gonna put in some windows today, so stay tuned. Hey, so here we are, part 2 of the window install. And I know we're gonna get to installing windows shortly, but if you remember in part 1, we prepped the window opening. We prepped it using stretch tape and the Zip family of products that are part of the Zip system. But I wanted to show you an alternative here before we get too involved in actually lifting a window up and putting it in place. So what I hold here is, these are some pre-manufactured flashing corners. They're by our good friends at Sega, and I'll dry fit this one. You'll see it basically is made to fit right in the corner there. It comes with a dual release tape on both sides, and you can see I had one installed here, but we're going to install this one here right before your very eyes. So yeah, we'll get the architect, get myself in trouble here by trying to play carpenter. So I just got this handy dandy flashing tool, and let's see here. See if you go down the seam and then flash that out, and then I can come back, work out all the kinks there, then fold the inside. Like I said, it's a dual release tape, which means basically a 2 parts, so it's not one backing. And like we did the other one, we'll stick the tool in here, and we'll get that corner set, and then work our way out of the corner in both directions. All right, so you can see we have both of our corners properly flashed there, and we'll set this middle piece. This is their larger flashing tape, and it also is a dual release, so we'll pull that one section apart, and then the goal here is I want to just bite the top of my back dam, have it come down, go across the slope sill, and basically make an attachment that bridges from my weather resistant barrier there to the top of my back dam. So we will just barely bite that. The problem with aggressive tapes is they're aggressive. But there we go. So take that, barely bite, handy dandy tool, and just tuck that down inside that back dam. I like this tool because it's got a nice blunt edge, tapered edge there that we can get right inside and then work this stuff out. Yeah, you get a little bit of forgiveness, but not a whole lot. We're spending half the video me pulling the tape off. So we'll take that, fold that down. Remember our goal, connect the back dam down the face of our slope sill. Across there. Yeah, and there you have it. A nice flash corner where we use the Sega pre-manufactured corners. We drop in our pan flashing there, and of course we'll finish this off by bringing our flashing down the side here, turning it in, and coming over the top of that. So anyways, just an alternative. Let's jump on over, and windows are here. You saw the truck. Let's start installing some windows. It is window install day. Yeah, we're done looking at those rough openings. Schüco truck arrived. You saw that coming in. And here we have our Schüco windows. Not only do we get the windows, but we get a design tech from Schüco. Armando, welcome Armando to Build Show Build Boston here. And Armando is here to make sure I don't screw up, right? Yeah. That's why they sent you. Make sure Steve doesn't do anything stupid with our windows. So you can see here, windows come very well packaged. We peeled the plastic off. You can see that they're fully protected when they arrive, and those are still in a protected truck. So they come out, we have the crate, break down the crate. All the windows are individually wrapped. A little bit about the performance of the windows, Armando. So the U value on these windows, it varies, right?
Yeah, it varies when you have a bigger system, or whether it's a fixed or operable. So it varies, the bigger the glass and all that, so it changes, yeah.
Yeah, so basically the glass is the better part of the window unit, right? Yeah. And for those of you that aren't familiar with the lingo of windows, we basically have the IGU, which stands for insulated glazing unit. That's the actual glass component of the window. In a fixed window, we just have the IGU in the frame, but if we have an operable window, the secondary frame that is the carriage of the glass is called the sash. Yep. And we have a lot of tilt-turn windows here, but as you were talking about, Armando, the size of the window matters to the performance. The frame is the worst part of the window, and the glass is the better part of the window.
I want to say yes and no. You still have a good value coming through your frame. We've done thermal testing on all these units.
And these are obviously all thermally broken.
Yep, they're thermally broken.
Put an aluminum window in.
Yep, and this system is a AWS 90. So it's the biggest of its kind, and the thermal value on it is very, very high. Right. So the frame, the glass, it all balances itself out, and that's what we try to do here.
Gotcha. And these, for those of you that are taking notes on the U values, these probably range anywhere from 0.13 on our best unit in the house to somewhere around 0.18 maybe on some of the smaller units. Again, you know, through the design work and working with Schüco, I'm trying to maximize the size of some of these windows because the glass is the better portion. Plus, we're trying to capture the view. So we're taking advantage of building those larger window units to capitalize on the view, the amount of glass, the efficiency of it, and just deliver the best possible project we can to our clients. So, Armando, we should head over there. We're going to break down one of the windows. Armando's going to go through all of the details that he brings from the factory and the design tech side, and we're going to talk about how we prep all these windows and get ready to put it in that rough opening. So let's head over to the table. We made our way over here. We have a nice little table we made up. Notice, just wanted to point it out, we have a piece of rigid foam that we set the window on. We didn't set it on the sawhorses. You don't know if there's a nail or a staple or anything there. We don't want to put our good aluminum frames up against the substrate there where we're at the risk of scratching it. So we got this up. First thing to notice there, Armando, is you guys do a hell of a job. Everything is very well protected here.
Yes, it is.
Right? I mean, you pull it out of the crate and then there's just a whole nother level of protection here. Obviously we have the foam on the corners there, top and bottom. We've already verified that, yes, this is in fact the bottom window, or the bottom of the window. So one of the cool things about working with Schüco windows, and you saw it in the factory, that, you know, pretty much all the screws, hardware, everything's proprietary. Well, the same with the clamps. You can see it has the Schüco name stamped right on it, and so it's basically the Schüco stamp of approval. Now, Armando, you pointed out a really significant aspect of these clips. You want to run that by us again? So
the clip is made so that you only rotate it clockwise and not counter. And the reason for that is so that it'll gain grip once it gets into position. So once you have it sitting at a angle 90 from your frame, it'll have the strength.
It'll be at its tightest bite.
Yep.
So yeah, let me bring this back over. You can see here that the actual teeth there are angled. So as it gets rotated, it actually draws the clamp in, and it's at its tightest, like Armando said, when it's 90 degrees. Now, installing these, you came up. I will say Armando is prepared. He came up. We have a window schematic of the window that we're installing here, and he has all the clamps laid out. I see we called for 6 down the side and then 4 at the top and bottom. Are there any rules of thumb that we should be concerned with, like how far these come out of the corner or placement?
So we actually had a third-party engineering team that came up with a schematic as far as how many strap anchors and how far apart, based on the PSF of certain systems, like if you need it for higher wind loads. So all that came down to it, and I took the schematics from that and I applied it into this, so that way we can actually.
So this third-party engineering company, they didn't engineer it just for us, they engineered it for Schüco. So if I was to say put these windows in Miami, because of the wind load there, or on the coast even here, that because of the wind load, these clips, instead of 6 down this side, it might in fact be 7 or 8 of them.
Yep.
So that we're getting a stronger bite there, right?
Yeah.
And I know just you told me that, typically we hold these in, the first one goes in about 4 inches on each side of the corner.
Yep.
And again, clockwise, so here we go. First one goes in, we rotate it, and you can feel that get drawn in, and that's it, right?
Yeah,
I mean,
that's pretty much
it's
it.
not a whole lot of magic. One of the beauties also, for those of you that don't have Armando showing up on your job site, we have an extensive installation guide here by Schüco that goes step by step for every aspect of the installation of these windows. So let's we'll finish up, we'll wrap up, we'll get the rest of these clamps ready, we'll get the window prepped, and in the rough opening she goes. All right, so we got the window clips all set. We're standing the window up. We're gonna throw it in the opening. Notice in the opening that we have a series of blocks that have been installed. Let's see if I can sneak through here. Excuse me, buddy. But you can see the block up at the top there. We have a mirrored one block here, and then we have 2 at the bottom. 2 things are happening with those blocks. One, they've been plumbed up by the carpenter to make sure that if we put the window up against them, that the window is then plumbed. We'll still check the inside with a level. But the other thing is, windows are not the cheapest part of the house, and the last thing you want to do is lift it, put it in the opening, and go to tilt it in, and the window falls out of the opening and ends up down on the ground. So those little stopping blocks not only preset the displacement of the window in the opening, but they also help keep the window from falling out of the opening. So let's get this window in, and then we'll show you the attachment sequence. All right, so you can see we got the window in. Christian's got it all screwed off. All of our clamps here, you can see they're screwed off. Now they're standing proud of the frame. Sometimes you could just bend those over with a hammer, but I like to just have the guys come and they'll grind those off, maybe about an 1/8 of an inch inside of the rough opening there. For those of you not familiar with Euro tilt-turn windows, so we have our tilt-turn window here. Obviously the handle is in the down position, that's the lock position. If I turn it 90 degrees, you can see that is the turn version, of the tilt turn window. That gives us the full ability to clean the window. Consequently, you don't open the window to vent like this. It is merely just to clean the window. If you're venting the space, then you rotate it another 90 degrees and you pull the window, and you can see it falls in about 7 inches and it becomes fully venting. The other beauty is that water now is a shedding device into the frame. And you know, when we were out there, we talked about it. It drops down into the frame, and you can see there's some weep holes down there inside that allows the water to go out. So not only are we having a water managed system of the window in the rough opening, but the window unit itself is water managed. So, all right, so the window's in, it's screwed off, we'll get those ground off. Now how do we finish the window? Well, let's talk about that for a second. Window's in, we just went over the operation of the window. You can see where's our 1/2 inch space there. That is the unit dimension versus the rough opening. Unit dimension plus 1 inch, we went over that. And that gives us the rough opening. Now, I talked about it earlier. The zip liner in the rough opening is to bring our weather resistive barrier around the corner. Now, whether you believe it or not, the window is a weather resistive barrier also. Because we cut a hole in there, we replace it, the opening or the sheathing that we cut out with the window. So it's now doing the job of the weather resistive barrier that would have been there if we had not chosen to put a window there. So now we have to make a connection from window and bridge it to that liner or that weather resistive barrier that we fold on the inside. Now, 2 things that we need to be concerned of. Number 1 is water. We need to solve for water managed system. We went through the whole deal here. You saw the video where we built the back dam, prepped the window, have it on blocks, windows sitting up on top of those blocks. Water can get out. We want to make sure no water has the ability to get in along the sides and the head of the window, but also air tightness. Now this house here, we're shooting for what I call passive house inspired. So we're not seeking certification, but we're seeking all the parameters of passive house. So we'd love to get this house into that kind of 0.5 or less air changes per hour at the 50 Pascal mark. So air tightness is very important to us. So we have a couple things happening at the window here. We have the 1/2 inch space here, but notice up at the top, we're relatively tight and we're relatively tight down here. There's a couple ways of doing this that I favor, and I'm pretty much good with interchanging these 2 different means. The very first and simple one is to just get some minimal expanding foam, and why I call for minimal expanding, it says no bowing basically, is we don't want the foam to apply any pressure and try and move that jamb. Now, for smaller double hung, double glazed windows, the frames there are a little more fragile than the European frames. These are about 3.5 inches square. They're very robust, triple glazed IGU. You're not really going to move those if we use something that wasn't minimal expanding, but hence I still like to do it. But basically we would just take that foam and we would spray it along the inside edge here and basically make the connection from the weather resistant barrier liner to the window itself on the inside. Given that the window's 3.5 inches, we're probably looking at this inside 1/2 inch of being filled up with this stuff. The remaining 3 inches there basically just open to the air on the outside for now. The second mode of operation here that I would approve of is to basically use a backer rod, and our good friends at Schüco using some big stretch, which they call it big stretch because it's made for big cracks. But for that, we would basically just simply tuck in that backer rod. And you can see, fits in there nice and neat. Now, that's a 1/2 inch hole. We're using a 3/4 inch backer rod so that it fits in there nice and snug. And then basically we would take that caulk and we would caulk that joint. Now, the beauty of the caulking is when we turn the corner, that joint is small enough where we can get away with just using the sealant there and not have to introduce any backer rod. The backer rod, you know, for a rule of thumb, if this starts getting past maybe about 1/4 inch, this doesn't want to stand alone. So you want to get that backer rod in there to reinforce it. Now, those are the two ways to seal the side or jamb of the window to that weather resistive liner. There's still one last step. The very last step, we turn to our friends at Sega. So we have 2 different rolls of tape here, 2 different sizes on those rolls. On the inside, we use, this is their Fentrum IS-20 tape, and the IS-20 tape is an impermeable tape. We don't want any moisture that gets in there to have the ability to dry this way. We want to force the drying to go to the outside. Now, the beauty of Sega tapes are they're dual release. So there's actually a flange here that you attach to the window, and then you can see that it comes off. So it's already pre-folded and all set up. I took the minute here to pre-install a piece so you can see it here. The flange, we just want to bite the window about, you know, maybe a little over an eighth, 3/16 or so, and then basically fold it up, and we would just take off that piece and then simply attach it to the inside. Now, from an air tightness perspective, we would do this across the sill, up the jambs, and across the head so that all 4 sides would have that continuous air barrier there. Now, one of Sego's logos is their job to seal up the world, right? So they're specialists in air barrier connectivity and air barrier technology with their Sega Myrex and their Reson tape. But that 2-part release and having it pre-folded, you can see that it's already set up for that 1/2 inch dimension damn near perfectly there. So we would run that around. Now we have our fully water managed system inside. We have our belt of either spray foam, the expanding foam, and or the backer rod with caulking, or just caulking if the joint is too tight. And then we'll finish off the whole system by enclosing it in this IS-20 Fentrum tape on the inside. As we move to the outside, we would then move to their other Fentrum tape. This is their 230. This one's gray, not white. And it is also a similar kind of tape. So it has that one section where it can be attached to the window, and you can see this is also dual release on the sides. So just like the inside, we would run that up the jambs and across the head. Notice that I made no mention of putting this tape down at the bottom. So on the outside, it helps to create somewhat of a tortured path, but it's really not an air barrier for me out there. Although, if you wanted to do this as a barrier system, this is a permeable tape, so we could very well put it on and do all 4 sides. I choose not to. I like to have the water managed system. I like to manage the air on the inside of the window. I place this down the jamb of the window all the way to the bottom of the window frame and across the top. So the top piece obviously overlapping it. So think of it as flashing. So the only place that air could get in is through the bottom of the window at the bottom of the sill. But with all of the action we're taking on the inside, I'm confident that we're going to get to our air tightness number anyway. So I'm not really worried about that. But that's how we finish off the install of the windows there. Hopefully that answers all of your questions. We got these beautiful windows in. That's one of about, I think, 38 windows here. We got some monsters going in, so next time we come out here, we're going to have windows in and we're going to be closed in. So until next time. All right, so I got my good friend Big Red in hand. I got some details down here, so you can see we grabbed the jam first. So I just want to talk about prepping that rough opening. I know we talked about that in the last video, but it's so important to get that basic concept down that I thought I'd throw up the jam detail here, and then we'll dive into the sill detail, which is you know, what you saw happening out there, installing the windows. So anyways, let's look at this. So here you can see this is our king and our jack, and I'll label them appropriately, king and jack. All right, king goes all the way up, jack goes up to the header. They form the rough opening. Now remember, we made the rough opening a little bit larger. You can see here we added a 7/16 inch, I call it a jam liner, right? And that is zip there. And the whole purpose of that is we had zip R9 on the outside here. And you can see we have all the rigid insulation happening there. But we really, you know, the minute we cut this section out of the wall to put the window in, right, then we need to maintain that level of continuity there. So by taking out that section of zip, we basically fold our weather resistive barrier around the corner. So if I color this in, that's probably the easiest way to understand the continuity of it, right? So you can see now our weather resistive barrier turns in, and our window, believe it or not, is also part of our WRB system, right? All of building assemblies are systems, right? They're not components, they're systems. So pay attention to that. It's, you know, everybody always thinks that the air barrier or the weather resistive barrier is one component. It isn't. It's the windows, it's some sealant, it's, you know, some foam, some tape, etc. But anyways, you can see the window frame basically finishes right there. That's the outer edge of the window frame. So we basically have that 1/2 inch in there that you can see. We filled that in with some foam sealant, and then we'll have that interior tape that we talked about there. So we get kind of a, what I would say, a belt and suspenders approach to our air barrier in there with that foam sealant and tape. But understand, our weather resistant barrier, it got folded in on all 4 sides, the sill, the jambs, and the head of the window opening. The window gets inserted, but the window falls short by roughly that 1/2 inch, and then we have to solve for that. So just wanted to get that. So let's jump. I'm going to grab the sill detail here, and we have that. This is the one that everybody always seems to like. Jam details are cool, head details. I give them more credit than most people, but everybody loves a great sill detail. So anyways, you can see here, this is what I would consider our rough frame sill, right? So we'll just call that RFS, rough frame sill. So that's the one that's part of the 2x6 wood frame enclosure. Now, on the jams, remember, we did our window unit dimension, and we added 2 inches, right? So there was a 1/2 inch for the RO, and then there was roughly a 1/2 inch for the zip, right? And that was on both sides. So we had the 1/2 inch here and here. Both of those are 1/2 inch. So 1, 2, 3, 4 1/2 inches, 2 inches. Yes, I can do math. But the vertical is slightly different. We have the rough frame here. We actually put in what I call a rip sill. In this case here, it just turned out to be a 2x8. But we'll call it the rip sill, because sometimes the wall, depending on what that dimension is, that rip sill will get cut to a very specific dimension. It might not be 7 1/4, it might be 7 1/8 or 6 15/16, who knows, whatever, depending on what's driving it out here. But the important thing is to understand, you can see our zip R9 is out here. Here's our 7/16 zip right there, and then our 1.5 here of polyisocyanurate. So zip R sheathing, if you haven't if you're not familiar with it, go check it out. I did some videos there when we were talking about wall framing and broke down with the sheathing that we were using on here. But the idea of the rip sill is that we go out over that, so it closes the fragile edge of that polyisocyanurate, as well as it gives me an 1.5 here to finish siding, rain screen, all of those things. If we just finished it here, we'd only have that 7/16 to nail in that way and 7/16 to nail in that way. It's really not substantial. Now, this is a point where kind of building science nerds will combat me, and we'll have a pretty let's say, we'll call it heated discussion, but they're going to call this a giant thermal bridge, right? Which undeniably it is. I mean, heat transfer goes right through that. At 7 1/4 inches inside to outside, it is probably at best maybe R10, something like that. Nah, it's probably not even that. It's probably more like R8. I'll give it R8. So that's probably about R8. And you can see the insulating sheathing doesn't go up there. But those that are familiar with me or have been around me long enough know that one of my common sayings is, if it doesn't last, it doesn't matter, right? We need to build very efficient buildings. We need to make the right choices. We need to pay attention to water management, air leakage, all of those things. But the number one concern that I have, and that was instilled in me as a young architect, is durability. Right? And say it with me. If it don't last, it don't matter. Right? I can build the most efficient, passive, zero energy, living building challenge house in the world. But if we're throwing it in a dumpster in 10 years or 20 years because it failed because of a water management issue or a structural deficiency or something like that, then what have we really done? We've used up a whole lot of resources and built a very efficient building for a relatively short time. Me, myself, I would rather build an exceptional building, not outstanding, but exceptional building, and have it last a very, very long time. And in that time, create very little maintenance, if any, to the structure, and try and minimize that as much as I can. So anyways, there's the rip sill. You can see here is that back dam that you saw out there. And then of course we had, we put in our sloped sill. That was our piece of cedar lap siding, and then we came over the top of that with our flashing that extended down, so that basically we've created this sill pan here, and you can see that that sill pan drains into our rain screen, which is right there, right? So it's going to drain in, and it's going to fall to gravity, and it's going to fall at the bottom of the wall where we have a provision for its exit. Remember, water management, right? The second word of that is not water barrier, it's not water stop, it's not water fighter, whatever word you want to throw out there. It is water management. The whole purpose of what we're doing here is to provide water a path to go should it get in. And if you don't believe it's going to get in, then let's just leave it at, I think you're being pretty naive about what you're building. So anyways, so for 30 years, I've been building buildings, and we've been taking apart older buildings. And one of the things I love to do is take apart older buildings slowly and see what mechanisms have failed over time there. So anyways, there's a reason why water is the #1 killer in buildings. All right, so we have our sill pan, and then you remember we have our metal clips. Those get attached to the window there. You can see the window unit here gets set in. On top of that, well, we have our little reverse blocks. So we have our little reverse blocks. Now it gets a little muddy in there, but we have the sill, remember, is sloping down. The whole purpose of the reverse block is to put the surface that we're going to place the window on back on a level surface. So if I take a piece of siding that is sloped, that's not the best piece, man. I'm having a hard time drawing here. So let's take a piece of siding that is sloped, and if I cut off a small chunk and then I reverse it and I put that chunk here, then this plus this inverted is going to give me a nice level playing field, right? And that's going to give me the ability now to set the window down and rest it on something that's level, but it also has this space underneath now that water, should it migrate in on the jambs or wherever, it's going to be able to leak down. Now, one of the important things there is, getting that foam or seal as close to that inside edge as we possibly can, within reason. And then, of course, you saw the detail where at the end I showed you that we would either put a backer rod and seal it in there, or we would simply tape it off. So either way, it works. It works very effectively. I mean, I've been doing a detail similar to this. This is probably the second time using this specific detail with the rip sill. I was just getting way too many comments about never having anything out here to nail to. And we have to put our sills in, we have siding and rain screen, a whole bunch of things terminating there, and not having anything to come in there. So anyways, that's a quick overview. Big Red did his job. We talked about window details, so hopefully you loved that episode. So enjoy. Long live our buildings.